Okay, so moving on to theme unit 1.8, which is inverse functions. Okay, so first of all, we have to be able to define an inverse function, and an inverse function is defined by the following statements. So you must know that only one-to-one functions possess inverses. So what does it mean to say a one-to-one function? So it's a function whereby f never takes the same value twice. So that is a one-to-one function, and only one-to-one functions can attain inverses. So basically not all functions have inverses, but only one-to-one functions. Okay, so in order to determine whether a function is a one-to-one function, we're going to use the horizontal line test. Okay, so the horizontal line test is whereby you plot a graph of the function and then plot any horizontal line, maybe at, for example, at y is equal to 1, and if it intersects the graph more than once, then it is not a one-to-one function. But if it only intersects the graph only once, then our function is one-to-one. Okay, so what you must know is that the domain of f inverse, so these are inverse function, this is how we represent it. So the domain of f of our inverse function is the range of our initial function, and the range of our inverse function is the domain of our initial function. So if you can get the range and domain of your initial functions, then you can get your domain and range for your inverse function as well. Okay, so basically this is how the inverse function is defined. So inverse function of x is equal to y, implying that our function of y is equal to x. Okay, so they are what are called cancellation equations. So these are equations involving inverse functions and the original functions. So the inverse and the original cancel out such that you have an easier value to work with. So for example, f inverse of f of x is just equal to x, and the same with f of f inverse of x. This one is just also equal to x. Okay, so there is a procedure on how you can obtain an inverse of any function. Okay, so how you go about it, the first step is where you have your f of x substitute with y, and then you make x subject to the formula. So you make x, you would take x to one side and then everything else to the other side of the equation. Okay, and then you interchange in the x and y. So where you have x, you substitute with y, and where you have y, you substitute with x. Then so your y becomes a f inverse, being equal to what you'd have gotten. Okay, so that's the theory behind inverse functions, unit 1.8. So moving on to the questions. Okay, so most of the questions are divided into logarithms and trigonometric inverses. So those are going to be dealt with in unit 1.9 and 1.10. So for now, I'm just going to do two questions showing how you obtain the inverse. Okay, so the question says find the inverse of f of x being equal to square root of 1 minus x. So our first step, we said wherever we have f of x, we are substituting with y. So this becomes y is equal to the square root of 1 minus x. And then you are now supposed to make x subject to the formula. So you take x to one side and everything else to the other side. So what I'm going to do, I'm going to square both sides such that I have y squared being equal to 1 minus x. Therefore, x is equal to 1 minus y squared. So this is our second step. We've made our x subject to the formula. Then now we interchange x and y. So it basically becomes y is equal to 1 minus x squared, like that. And then, so where we have y is just f inverse of x being equal to 1 minus x squared. And that is the final function. That is your inverse function. So when they ask you to get the domain and the range of your inverse function, You see that with this one, our domain would be 1 minus x being greater or equal to 0. Therefore, your x being less than or equal to 1. Okay, so your domain of our function x will be equal to, so it's less than or equal to 1. So it's negative infinity up until 1 included. So that will be your range of our inverse function. And then the range of this function is going to be 0 going upwards, so it's the positive square root. So a positive square root always starts at 0 going upwards. So the range of f was going to be, so it's 0 included up until infinity. So now this becomes the domain of f inverse, the range of f inverse, and then this becomes the domain of f inverse. Okay, moving on to the next question. It's f of x being equal to x plus 4 over 2x minus 5. Okay, so this is y being equal to x plus 4 over 2x minus 5. Okay, I'm going to multiply throughout by 2x minus 5. Then this side as well, 2x minus 5. Such that now I have 2xy minus 5y being equal to x plus 4. Then 2xy minus x minus 5y minus 4 being equal to 0. So now I'm basically making x subject to the formula. I'm going to factor out x such that I have x 2y minus 1 being equal to 5y plus 4. So I've taken these to that side. And then I divide throughout by 2y minus 1 over 2y minus 1, such that I have x being equal to 5y plus 4 over 2y minus 1. And then I interchange x and y. So it's going to be y being equal to 5x plus 4 over 2x minus 1. Then your y is f inverse of x being equal to 5x plus 4 over 2x minus 1. Then you can find the domain in the range in the similar way as we did with this one. So that's theme 1.8. So next one we move to theme 1.9. Okay, so theme 1.9 is logarithmic functions. So in short, log functions. Okay, so the function f of x being equal to ax, our exponential function, is an inverse function. So the inverse function is equal to log x to the base of a, which is known as the logarithmic function with base a. So this, our log function, is the inverse of our exponential function. Okay, so when we're dealing with logarithms in WTW 158, we'll mostly be dealing with the natural logarithm. So the natural logarithm is represented by ln, so it's ln and then a number, ln, maybe let me just say ln x. Okay, so f of x, so the natural logarithm f of x being equal to exponent of x, then you find the inverse of that, it's log x to the base of e, but then that is just labeled as ln x. So please make sure that you do not use log x to the base of e. Just use ln x, as they will mark this one wrong. So please just practice to use ln, because that will be the one that you'll be using most of the time in WTW 158. Okay, so what it basically means is y being equal to ln x implies that exponent of y, so you can take this on that side using laws of logarithms. So exponent of y is equal to x. So it's basically a mixture of laws of logarithms and exponents. Okay, so properties of our natural logarithm function. The first one, ln AB, so it's ln A times B is equal to ln A plus ln B, where your A is greater than 0 and B is greater than 0. Okay, and then ln A over B is equal to ln A minus ln B, where A is greater than 0 and your B is also greater than 0, because ln does not intersect the zero axis. So our ln starts from numbers above 0. So it can never be, you cannot have the ln of 0 or a negative number. Okay, so now we have also ln A to the B is equal to B ln A, and your A is greater than 0. Okay, and we have cancellation properties of our natural logarithm. So the first one is ln exponent of x being equal to x, and x is an element of all real numbers. And then exponent of ln x is equal to x, and in this particular case, since we said ln cannot take any numbers from 0 going downwards, or x is to be greater than 0. Okay, and lastly, ln e is equal to 1. So this is all you need to know about the logarithmic functions and your natural log. So now I'll move on to examples and questions. So our first question says, express each logarithm as a sum or difference of simpler logarithms. So we'll be given logarithms maybe as quotients and products, and we just have to make them sums and differences. Okay, so the first one, it's log xy over z. So according to our laws, log xy is just log x plus log y, and then everything over z, so that's minus log z, just like that. So that is the solution for the first one. And the second one is ln of the cube root of x squared plus 1. So what you're going to do with this one, you first of all write it in a simpler way. So it's going to be ln x squared plus 1, and then to the power of 1 over 3. Okay, so from here we can drop this one down according to our laws or properties of logarithms. So it's 1 over 3 ln x squared plus 1. So this one just stays as it is. You cannot further simplify it unless if there was a multiplication or division sign within this bracket. Okay, and lastly we have ln x plus y, everything to the power of 3 over xy squared. Okay, so with this one you can separate it into two parts already. So that's ln x plus y cubed, then minus ln xy squared. Then this one you can drop it down, you can drop down 3, so you're going to have 3 ln x plus y. Then with this one now there is a multiplication sign in here, so it's a product, so it's minus factor of ln x plus ln y squared. And then ln y squared can be 2 ln y, so that's 3 ln x plus y minus ln x plus 2 ln y. And this can be further simplified to 3 ln x plus y minus ln x minus 2 ln y, which is quite simple to follow. Okay, so our next question says, if log 2 to the base a is equal to x and log 3 to base a is equal to y, express each of the following in terms of x and y. Then you have your first one as log the cube root of 6 to the base a. Okay, so with this one, it's best to write it in simpler terms at first. So that's log base a, 6 to the power of 1 over 3, so that's 1 over 3 log a 6. But we do know log 2 to base a and log 3 to base a. So this one can be written as 1 over 3 log base a, and then 2 times 3, because that is 6. 6 is 2 times 3. Then you can split them. So you have 1 over 3 log a 2, then plus 1 over 3 log base a of 3. And then when you have something like this, then you can just substitute. So log 2 base a is equal to x, so it's 1 over 3 x plus 1 over 3 y. Then you can factor out 1 over 3 such that you have 1 over 3 x plus y as your final solution. So it's just a matter of, first of all, simplifying using, so it's quite complicated when you see the cube root, but you can easily write it as 1 over 3, drop down the 1 over 3. So just manipulating our laws of logarithms. Okay, and then the next one is log 2 over 9 base a. Okay, so with this one, using our laws of logarithms, so first of all, we're going to simplify it again. So it's log a2 minus log a9, but 9 is 3 squared. So it's log a2 minus log a3 squared, and then this 2 can be dropped down. So log a2 minus 2 log a3, and log a2, this is x minus 2y. This is the final solution. So the next question says, if log b to the base of a is equal to 3, find log a to the base of b. Okay, so with this one, what we're going to do is, okay, so with this one, it's log b base a is equal to 3. Okay, so let's just rewrite it. Then using our laws, the combined laws of logarithms and exponents, we're going to have a being equal to b to the power of 3. So this one steps up, and then this one steps to the side, and then the 3 goes up. Okay, so if a is equal to b to the power of 3, what is b? So b is equal to a to the power of 1 over 3. And if we have that, then now we can just step down everything now. So you're going to have your log b a being equal to 1 over 3. So you basically you stepped up everything over here so that you can remove the log, and then you found an expression for b, and then you step down everything. So b goes down, a goes that side, and 1 over 3 goes down as well. So this will be your final solution. So you just have to know when to step down and then step up. So when you're going from log to just symbols and numbers, you're going to be stepping up, and when you're going from symbols and numbers to log, then you're going to be stepping down. So the next one says, if log of 1 over 10 base b is equal to negative half, find b. So I want to find b. So basically we're coming from log to numbers and symbols, so we're going to have to be stepping up. So over here, our b is going to be 1 over 10 to the power negative half, which is equal to 1 over 10. So it's 1 over 1 over 10. And then this 1 over 10 is to the power of a half. And then using our laws of exponents, so that's going to be 1 over 1 to the half over 10 to a half, like that. Then which is equal to 1 over 1 over 10 to the power of a half. So 1 over 1 over 10 is just equal to 10 to the power of a half, which is the square root of 10. So that's your value of b. So just step up everything and then start working like a normal equation, then solve for b. Okay, so for the next set of questions, we have to simplify. So we're simplifying the square root of exponent of x times the cube root of exponent of negative 3x. Okay, so using laws of exponents, it's going to be, I'm just going to write this without the square root, but the powers in fractional form. So that's to the power of a half, and multiplied by exponent of negative 3x, power of 1 over 3. That should give us exponent of x over 2, because this one multiplies that, times exponent of negative x, which becomes exponent of x over 2 minus x, exponent of negative x over 2, being your final solution. So if you just learn how to apply the laws of logarithms and exponents, then you'll be quite good. And then this will come easier for you to do. Okay, and then the second one, it's ln exponent of 2 plus exponent of negative ln x. So over here, according to the cancellation equations, I write this one as 2 ln e plus exponent of ln of x to the power of negative 1. And this one, ln e is just equal to 1, so that's 2 plus exponent of ln x to the power of negative 1 is x to the power of negative 1, which is 2 plus 1 over x. Then you can just simplify it to get 2x plus 1. And obviously your x, so from here, your x has to be greater, or it has to be greater than 0. So x is greater than 0. You just have to write them down so that the marker actually knows what you're doing. So the next set of questions is solve for x, and the first one is exponent of 2 ln 3 is equal to x. So this one, according to cancellation equations, exponent of ln 3 squared being equal to x, and then exponent of ln 3 squared is just 3 squared being equal to x, and your x being equal to 9. So you're just using the equations as plain as they are. So with this one now, we're going to apply both the cancellation equations and the normal equations and laws of logarithms and exponents. Okay, so for the first part, once you find something like this, then you just can divide by the ln function and then you get your final answer. You actually have to go through all the processes. So over here, you know that this is the same as ln x to the power of a half being equal to 1 minus ln 2. Okay, and then you can take exponents on both sides so that you can remove this ln, so that you can be left with the x alone. It's ln x to the half being equal to exponent of 1 minus ln 2. And this one, according to exponential laws, it's exponent of 1 over exponent of ln 2. And then this one is x to the half, x to the power of a half. So x to the power of a half is equal to exponent of 1, and this one is just equal to 2, since it's exponent of ln 2. Okay, and then you square both sides so that you get rid of the half, so that you're left with x being equal to exponent of 2 over 4 as your solution. Okay, so now that we know all our exponents and our logarithms, now we can use them to determine the inverses and the domains of the inverses of logarithmic and exponential functions. Okay, so the first one says determine f inverse and the domain of f inverse. So the first one is f of x being equal to x cubed plus 2. So first step, y is equal to x cubed plus 2. Then x cubed is equal to y minus 2. Then you find the cube root. So it's x is equal to y minus 2 to the power of 1 over 3. And then substitute with y, we interchange, so y is equal to x minus 2 to the power 1 over 3. So you can write this one as the cube root as well. So you can write it as cube root x minus 2. It's just the same. But I do prefer this way because it's easier to understand. It's simpler to see that if I want to change something, then I just have to multiply by power of 3 or something like that. Okay, so the f inverse of x is equal to x minus 2 to the power of 1 over 3, which is equal to the cube root of x minus 2. Okay, so we also have to find the domain of f inverse. So one thing you should know about cube roots is that even if there's a negative number here, even if it's 0, even if it's -2, -3, etc., you can still get the cube root of a negative number. So the cube root of a negative number exists. It's a real number. So, or you can just go to your f of x, which was x cubed plus 2, and you see that the range was all real numbers. So the domain of f inverse is just equal to the set of all real numbers as well. Since the domain and the range, they are the same, and the range and the domain are the same as well. Okay, the next one is f of x being equal to 2 times exponent of negative x. Okay, so first step, y is equal to 2 exponent of negative x. Okay, then y over 2 is equal to exponent of negative x. So now to make x subject, we're going to use the logarithmic function, the natural logarithmic function. So it's ln. So I'm going to put ln on both sides. So it's ln of y over 2 being equal to ln exponent of negative x. Okay, so this becomes ln y minus ln 2 being equal to negative x ln e, and ln e is just equal to 1. So you're left with ln y minus ln 2 being equal to negative x. Therefore, ln 2 minus ln y being equal to x. Then we interchange. So y is equal to ln 2 minus ln x. F inverse of x is equal to ln 2 minus ln x, and then this one you can also rewrite it as ln 2 over x from the laws of logarithms. Okay, so we also need to find the domain of f of x, and we can do that by looking at the range of our f of x, of our initial function, and this was supposed to be, which is all positive values. So it's 0 to infinity, but 0 not included, because it's an exponent, and an exponent is always positive. So our domain of f inverse of x is equal to 0 to infinity, like that. Also, you can even look at this part. We know that ln can be negative and the denominator cannot be 0, so it's a positive number. So that's why we have 0 to infinity. So that's that on unit 1.9. Now move on to unit 1.10.